In this video, I would like to teach you how to determine whether a certain expression is a factor of a polynomial. Let's look at a specific example. So is x minus 2 a factor of 4x to the fourth minus 15x squared minus 4? To do this, we have to understand what it means to be a factor first. So very simply, imagine I give you the value of 12. And I'm going to ask you, is 2 a factor of 12? So all you have to do is figure out whether 2 divides evenly into 12. And if it does, it gives you a whole number. There is no remainder. And then we can clearly state that 2 is indeed a factor of 12. All right. Now, that turns out to be the key. What we need to do is we need to determine whether, when we divide this thing into that thing, whether there is a remainder or not. Okay. If there is no remainder, meaning if the remainder is 0, then this will be a factor. If the remainder isn't 0, meaning it's some non-zero value, well, then this won't be a factor. And how are we going to do that? Well, wait, do you hear that? Synthetic division time. That's what time it is, ladies and gentlemen. Here we go. Bam. So the first thing we're going to do is develop this synthetic division table. What I got to do is I got to look at my polynomial function. I have to identify the highest power of x, and what I'm going to do is add 1 to it. And when I do that, I come up with a total of 5, and that's going to tell me the number of columns here that I'm going to need inside of my synthetic division table. Okay, and basically now this will represent the coefficient of x to the fourth, this will represent the coefficient of x to the third, this is x squared, this is then x, and this is then your constant term, okay, on the top. So now all you got to do is look back. If you don't have a coefficient now for, let's say, these terms, which you don't in that particular polynomial function, just place in 0. Okay, that's all. Then go back to here, and your coefficient of the x to the fourth term is going to be a 4. Then the x squared is going to be a negative 15, and your constant was going to be a negative 4. Great. Now I'm just going to erase this so this doesn't confuse us later. Then take a look at your divisor, or the thing that you're trying to determine whether it's a factor or not. X minus 2, set that thing equal to 0. Solve that for x, and what this is going to allow you to do, it's going to allow you to determine the number that's supposed to go outside of your synthetic division table now. After we have the top row fully filled out, just a simple series of steps. Drop down this coefficient all the way to the bottom. And then you're going to multiply these two. 4 times 2 is going to be a total of 8. That goes in the next adjacent cell. Then add these terms together. That's going to be a total of 8. Then all you're going to do, take this new term and multiply it by that outside term. So 8 times 2 is going to be 16. Plug it into the next adjacent cell. Add them together. That's going to be a positive 1. Then take this, multiply by that, and that's going to come out to be a total of 2. So simply plug that in there. Add it together. That's a total of 2. And then take this term, multiply by that outside term, that's going to be a total of 4. Add this column together, and lo and behold, we get the magic number of 0. Now this, and the reason why the box is in green, is because this box represents your remainder. If your remainder is 0, which it is in this case, then we know that this thing divides into that thing evenly. There is no remainder, and therefore this is indeed a factor of that. Thanks for tuning in, ladies and gentlemen. I really do appreciate it. If this video helped out at all, like, subscribe, maybe even tell some of your classmates. We'd love to help more people. And if you're taking some other classes like chemistry and physics, whether you're in high school or college, we have thousands of problems out there for you. Okay? We have thousands of solved examples. We'd love to help you with specific problems, okay? Take a look. Yeah, just take a look. We'll see you.